gas laws. We've covered the first four, which is just using P, V, and T, which is pressure, volume, and temperature. Remember, there's always a pressure 1 and a pressure 2, a volume 1, volume 2, and then temperature 1, and then temperature 2 as well. So we're familiar with those three, P, V, and T. Also the units. Remember that pressure, you can use atmospheres, kilopascals, millimeters of mercury, and torrs. Always remember that those four are for pressure. Then for volume, always use liters. Remember to convert, if you have to convert from centimeters cubed to or milliliters to liters, remember to convert that by moving your decimal to the left 3 times. And then also remember that temperature is always in kelvins. In a science class or laboratory setting, you want to use kelvins, so then you would add 273 to Celsius in order to do so. So P, V, and T you're familiar with from a previous lesson. We're going to cover now today in this lesson your ideal gas law. Ideal gas law, which is PV equals nRT. You can see the formula up here. PV equals nRT. PV equals nRT. That is your ideal gas law formula. You are familiar once again with the P, the V, and the T. Pressure, volume, temperature. PVT. There's 2 that you may not be familiar with, or you need a reminder. Your N is number of moles. Your N is always number of moles for ideal gas law. So remember that you've worked with molar mass before. You use your periodic table, then you would multiply your average mass on the table by how many atoms of the element you have. That is your molar mass, Mn. N is number of moles, which is your mass over your molar mass, or grams over molar mass. Sometimes you may not have to solve for this. For the first example that I have, you don't have to solve for it. It's just a good idea to have it in the back of your mind because you will use this later. N is mass over molar mass. Number of moles is mass over molar mass. Mass is measured in grams. We know that already. And then your molar mass is grams over mole. We've already done that with your periodic table. And then you're going to multiply, once again, the number of atoms you have of the particular element by, in order to figure this out. So, PV equals nRT, pressure, volume, number of moles. We're familiar with that now. And then temperature. Your R is a constant. It's always given to you. You do not solve for R. It's given to you already. R is a constant. Where is it given to you? There's 2 pieces of paper that would be very helpful if you have this out as you're listening to this lesson. The first one says ideal gas law problems at the top. Ideal gas law problems at the top. This is 1 through 12. There's 12 problems on this particular lesson. Ideal gas law problems at the top, 1 through 12. And then there's the packet that has all of the formulas in front of you. The front page has all of the formulas. It says a Boyle's law, Charles' law, Gay-Lussac's law, has a combined gas law, it has a pressure law, Graham's law, and then ideal gas law as well. It has all of your formulas and your variables on it. You want to look for that. If you look at the bottom right, where it says gas laws, equation symbols, your bottom right, there is a capital R right there. There's a capital R. That is your constant. There's 3 options for that. There are 3 options for your R constant. You'll notice there that there are 3 different numbers with 3 different units. The units vary based on pressure. I need you to pay attention to this. The way you can conclude which R to use is by what unit of pressure your problem provides. Remember that pressure could be atmospheres, torrs, kilopascals, millimeters of mercury. In this instance, your R can be kilopascals, atmospheres, or torrs. Those are the 3 options. You want to look at the R. I would suggest that you circle it, that you highlight it, that you make a note of it, that it's right there so you can locate it quickly next time for your problem. So your R is right there. You can either use 8.31, that's for kilopascals. 8.31 is for kilopascals. 0.0821, that is for atmospheres. You can see there's 62.4 is for torrs. Depending on the pressure that you're using, that's the R that you're plugging into it. So don't stress about solving for R. It's given, you just have to locate which one of the 3 am I using. So pressure pressure, volume, number of moles, constant temperature. PV and RT. Those are letters you should be familiar with. You need to start memorizing them and what they stand for. So my formula initially is PV equals nRT. PV equals nRT. That is my formula. Once again, ideal gas law is PV equals nRT. Pressure times volume equals my number of moles times my R times my temperature. Pressure and volume are multiplied by number of moles, my constant, and my temperature. Always, when you begin doing your ideal gas law, always start off by writing out your formula. Eventually, you'll get a lot more familiar with this. You'll feel a lot more comfortable. That does not mean you skip this step. Always remember to write your formula out. Even if the problem already has most of it solved, even if the problem seems short, even if the previous problem you can see the formula, rewrite it every time. Get into the habit, and that'll help you understand this a lot better. PV equals nRT. Now, depending on your problem, you'll also notice that you might have to rearrange your formula. You stick with the original, PV equals nRT. You just rearrange it to format according to the problem. So I'm actually looking at ideal gas law problems. The worksheet I gave you says ideal gas law problems at the top. And I'm looking at number 1. This is the first example. I'm going to read it out loud and show you how I rearrange this formula. It says if I have 4 moles of a gas. Now remember, moles is N. N is number of moles. So your N is already given. You don't have to solve for it. N is given. It says if I have 4 moles of a gas at a pressure of 5.6 atmospheres. Again, pressure is also given to you, so your pressure and your number of moles is already given to you. Then it says a volume of 12 liters. 12 liters is volume, so your V is also given. Your pressure, your volume, and your N. Your P, your V, and your N are already given to you. And remember that your R is constantly always given to you. It's a given, it's a constant. So you just look on your sheet of paper with the formulas, which R am I going to use? As you look at the problem, it says a pressure of 5.6 atmospheres. So since I am using atmospheres, I will locate that on my R constant, bottom right, and I'll see that my R constant for atmospheres, once again, is 0.0821. 0.0821. So your R is given, your N is given, your pressure is given, and your volume is given. Your P, your V, your N, and your R. So that means you're solving for temperature. You can see it in the problem. What is a temperature? Because you are solving for T for temperature, you're going to have to leave it by itself. You want to move this entire side except for T on the opposite side in order to solve for it. So I left T by itself on the right side for temperature, and I'm going to move over my N and my R. In order to do so, I need to divide this side by NR, and then this side by NR. Whatever you do to one side, you have to do to the other side. So I rearranged it. PV over NR equals T. I move the NR over to this side by dividing it. PV over NR equals T. You might have to rearrange it. Once again, if you're solving for pressure, you would move volume over to that side. Pressure equals nRT over V, and so forth. It's just a matter of moving what is unnecessary on the right side or the left side in order to isolate or leave what you're solving for by itself. So by rearranging my formula, now I know that temperature is equivalent to pressure times volume over moles times my constant. All of these are given to me. Remember, all you have to do is plug them in. So we're going to do that on this side. I'm going to put in pressure and volume at the top, and then number of moles and my R constant at the bottom. 3 out of the 4 are very easy. The 4th one is just takes a matter of practice. So my pressure, of course, as we've already said, is given to me in the problem. My pressure is 5.6 atmospheres. I'm just going to put 5.6 atmospheres. That's my first pressure. Then my volume is also given to me in the problem, 12 liters. I'm going to put it right next to it, 12 liters. Underneath it, I have to put my number of moles and my R. My number of moles and my R. What's my number of moles? Given right there, 4 moles. Then my final thing is my R, which is my constant. I have to locate it. We've already mentioned it's right there. It's 0.0821. That's my number. Now you'll notice that it is a lengthy unit. It's pretty long that you have to plug in, so you have to make sure you leave some space. You have to copy it exactly how it is on your piece of paper. So it's 0.0821. Then you'll notice that it is liters atmosphere over moles Kelvin. Liters atmosphere over moles Kelvin. That is my unit for my R constant. Liters atmospheres over moles Kelvin. Seems kind of odd. Put parentheses around that. It's lengthy, but we'll show you here in a second how all of these cancel each other out. And then I'll put equals temperature because I'm solving for my temperature. Next thing is, everything else after this becomes a lot easier. You're going to cancel out your units. You're going to multiply across the top first, then the bottom second, and then divide, and then you get your final answer. So once again, let's start off by canceling off my units. So you'll notice that atmospheres is at the top, atmospheres is at the bottom here. I can cancel those out. Then you'll notice liters and liters. You'll notice mole and mole. The only unit that is left is K for kelvins. K for kelvins. So because only kelvins is left, first, I know I'm doing this problem correctly because I'm solving for K, which is temperature. So I've isolated everything. I moved it to the correct side. I've canceled out my units that are unnecessary. I'm only left with K right here. So then what you're going to do is you're going to multiply across the top first and then the bottom. 5.6 times 12. You do 5.6 times 12 at the top, and then you're going to do 5 times 0.0821 at the bottom. So at the top, we're going to have 67.20. Remember, you cancel your units out, so you don't have to worry about that. And then 4 times 0.0821 is going to give me 0.3284. You want to use the entire number provided to you by the calculator in order to have the most accurate answer. When you have your final answer, you do want to limit it to only 2 decimal places, as we've already discussed. So 67.20 at the top, and then 3284 at the bottom, and then you just divide both of these. That'll give you kelvins, which is your temperature. When you divide both of these, you should get 204.63. 204.63. That is kelvins. You divide this by this, gives you 204.63. Again, the only tricky part about this is, first and foremost, remember your formula, remember how to rearrange it, remember everything that it stands for. Once you're done with that, all of this has a place within the formula. Pressure, volume, number of moles, R constant. Do not be intimidated by your R constant. It's already given to you. Remember to write out your units so that they cancel each other out. To give you a piece of advice and a shortcut for the purposes of later on, you don't actually have to write out your units. This is just me showing you where all of these units disappear and how to double check your work to see, am I doing this and arranging this correctly? If you can arrange it, cancel out your units, be left with the only one that you're solving for, you know you're doing it correct. You don't have to second guess yourself. For the future, you don't have to write out your units. Just remember at the end of the problem to put the correct unit. If you would not have put Kelvin, that is incorrect. If you would have put Celsius, that is incorrect. If you would have put atmospheres, liters, moles, those are all incorrect units. It has to be kelvins for temperature. So once again, arrange your formula exactly for what it is that you're solving for. Always rewrite it. We mentioned that already in your problem. Then rearrange it. Once you rearrange it, copy it once again. Instead of putting the letters, put the numbers that correspond to each one. Divide, multiply across at the top, first, then the bottom, then divide.